Now, a team of scientists at Melbourne University is fine-tuning new strains of rice and wheat that could help feed hundreds of millions of poverty-stricken and malnourished people around the world. Iskander Razak reports.
These tiny grains could hold the key to fixing a range of illnesses affecting billions of people. This is rice that scientists at Melbourne University have genetically modified to be rich in iron and zinc.
Iron deficiency is the most prevalent micronutrient deficiency in the world. It impacts on at least 2 billion people, and many of them are in developing countries.
Yeah, it looks very good.
A lack of these nutrients can cause anemia and stunt growth, including brain development in children. Most of those affected live in the poorest parts of the world, where people survive on just rice, wheat or beans. Since 2007, the team at Melbourne University has been working on changing rice. And they've had some success.
We've produced genetically modified rice, where they produce higher levels of a rice gene, which have 4 times more iron in the grain and 2 times more zinc.
That rice is in the middle of field trials in the Philippines and Colombia. The team is so confident about its program, it's also working on wheat. That's a much harder process.
But rice is easier, yes, in everything. It has less DNA to start with, it has a smaller genome.
But the wheat project is also looking promising. An iron-rich wheat will be planted in field trials in May. Genetically modified food, though, is not without its controversy. Critics against GM say they're concerned that it might be harmful to the environment as well as human beings in the long run. Opponents to genetically modified foods have destroyed GM crops around the world. One of the most strident critics has been Greenpeace, and in Australia, Greenpeace has targeted GM canola and wheat plantations. So the team at Melbourne University is also trying a different way of creating iron-rich grains. It's called tilling.
Tilling allows you to create mutations in a gene, and we're again focused on this gene, which controls iron uptake from soil. But you can make mutations and they're not classified as genetic modifications. The reason why we're trialing tilling is to give us a non-GM approach to biofortification, and that can be useful because there's parts of the world right now where GM crops are not widely accepted.
And that has groups like World Vision Australia excited. Many aid agencies run dozens of food projects around the world.
In Africa, there's hundreds of millions of people that we're trying to reach, and then when we talk about something like rice, I think you have to look at billions of people.
So having an iron-rich rice to give to the poor that isn't genetically modified could sidestep the controversy while also helping billions of people.
I love the work that they're doing here in this lab. I think also working on rice, that's why I get excited, because that's one of the crops some of the poorest farmers are growing rice, and some of the biggest advantages could be had by growing these biofortified crops.
But despite the enthusiasm, everyone agrees enriched grains aren't a complete solution.
It would be great to have grains which are enriched in iron, zinc, and vitamin A. But I think what we would really want one day is people to have a very diverse diet. So that's not going to happen in my lifetime. There's, rice, wheat, and maize contribute 50% of the calories that humans consume. But one day, if we can get everyone healthy enough with biofortified cereals, they'd be more productive, they could afford a more diverse diet. And I think that would be what we're aiming for.